Before moving on to the next lesson, please try this warm-up. Expand and simplify. Pause the video, see if you can do it, and then come back and see how you did. Expand means multiply it out. So if you see a number in front of brackets, it just means each term inside the brackets is multiplied by the number in front. So 2 multiplied by x is 2x. 2 multiplied by 5 is 10. So this is 2x plus 10. Over here, x minus 5 in brackets gets multiplied by 4x. So 4x times x is 4x squared. 4x times negative 5 is negative 20x. So I end up with 4x squared minus 20x. This is called the distributive law or the distributive property, and this is what we're going to extend in this lesson. We're starting a new unit about polynomial functions, and a big part of that is algebra. And so we're going to start with review of the distributive law and factoring. So factoring is something that you started learning in grade 10, continued on in grade 11, and we're going to keep going with it in this course as well. So hopefully by the end of this lesson or the end of this unit, you'll be able to successfully apply the distributive law to multiplication of monomials and binomials. So multiplying out polynomial expressions and also factor expressions successfully. So we're going to do a lot of practice on factoring in this lesson. It is technically review, but you might not feel comfortable with factoring. Hopefully you'll feel a little bit better about it at the end of this lesson. So we'll start with a few examples of the distributive law. So we're going to expand and simplify the expressions. So here, just like in the warm-up, I have two terms in the brackets being multiplied by one term in front of the brackets. So this is a polynomial expression, a binomial being multiplied by a monomial, if you want to get technical. So each term in the brackets gets multiplied by the term in front. So 4 times x is 4x. 4 times 2 is 8. So we have 4x plus 8. Now just like here, each term in the brackets gets multiplied by the number in front of the brackets. Here we have two terms in the brackets getting multiplied by two terms in front of the brackets. So the way you can think of this is each term in the brackets gets multiplied by each term in the other set of brackets. So x gets multiplied by x. X gets multiplied by 2. 4 gets multiplied by x. 4 gets multiplied by 2. So I end up with x squared plus 2x plus 4x plus 8. Now, that's expanding. Now let's look at this part, simplify. Simplify just means collect your like terms and add them together. So here I have like terms, 2x plus 4x. I can simplify that. 2x plus 4x is 6x. So really I end up with x squared plus 6x plus 8. And this is that distributive law or distributive property. Each term in front gets multiplied by each term in the brackets. Let's keep going. In these two expressions, we're doing the same thing. We're going to expand and simplify, but they're just a little more complex. Okay, so just here, we have this big term, everything's being multiplied together, and then we add this term at the end. Here we have a bunch of things being multiplied. Why don't you pause the video and see if you can do this on your own, and then check back to see how you did. Here I've done the first one. I went ahead and I multiplied the two brackets together first. So x times x is x squared, x times 2 is 2x, minus 4 times x is minus 4x, minus 4 times 2 is minus 8. Then I noticed I had like terms in the middle. 2x minus 4x is minus 2x. Now I have simplified that, but it still has that 4 in front, so I got to multiply everything by 4 now. 4 times x squared is 4x squared. 4 times minus 2x is minus 8x. 4 times minus 8 is minus 32. And I still have this plus 3x at the end as a separate term. But I have like terms. Minus 8x and plus 3x are like terms, so minus 8x plus 3x is minus 5x. So I simplified the whole thing to 4x squared minus 5x minus 32. Now, the next one. I'm doing the same thing where I'm multiplying the brackets together first. So x squared times x is x cubed. X squared times minus y is minus x squared y. Minus 3y times x is minus 3xy. If you wrote minus 3yx, it's the same thing. I just like to put my variables in alphabetical order. And then finally we have minus 3y times minus y. Two negatives multiplied together give me positive. 3y times y is 3y squared. Okay, so I've multiplied my brackets. Now I look for any like terms. Doesn't look like I have any here. So now each term in the brackets gets multiplied by minus 2y. So negative 2y times x cubed is negative 2x cubed y. Negative 2y times negative x squared y. Well, two negatives, so it's plus. Okay, 2. The x squared and y times y is y squared. So we have plus 2x squared y squared. Negative 2y times negative 3xy is positive 6xy squared. And then lastly, negative 2y times positive 3y squared is negative 6y cubed. So hopefully you could get through that. It's a little more complicated than before, but the process is the same. Multiply all your brackets together, and then multiply by the number in front. So we've looked at expanding and using the distributive law to do that. Now we're going to look at the opposite. So factoring is the opposite of expanding. So in the previous example, we started with something like this, and we multiplied it out, simplified it, and we ended up with this. So going this way, we called that expanding. But what if I start with this and I want to turn it into this? So I'm working this way. Well, that's the process called factoring. Okay, so we're basically going to be working backwards from what we were doing in the previous example. So when you first learned about factoring in probably grade 10, maybe grade 11, you would have looked at this idea of common factoring. Okay, so when I say common factor, I really mean the greatest common factor. So if I look at this first expression, 7x minus 14, I look at my two terms, 7x and minus 14, and I have to think to myself, what is the greatest common factor of those two terms? Okay, well, I look at the number 7. Factors of 7 are, well, 1 and 7. 1 times 7 is 7. Nothing else multiplies to get 7. So the factors are 1 and 7. Okay, factors of 14, well, 1 times 14, so 1 and 14 are factors. 2 times 7, so 2 and 7 are both factors, and nothing else. What's the greatest common factor? Well, 1 is a common factor. 7 is a common factor. 7 is the greatest common factor. So I went through that in excruciating detail so that you can kind of figure that one out. Regardless, for this expression, 7 is my greatest common factor. So if 7 is one of my factors, what's the other factor to get me an equivalent expression? Well, I can think of it, what multiplied by 7 gets me 7x minus 14. Because remember, I'm working backwards from expanding. So I know x times 7 gets me 7x, and minus 2 times 7 gets me minus 14. So the factors of 7x minus 14 are 7 and x minus 2. So now the expression is in factored form. It's more complicated when you have more than one term and you have more than one variable. You've got exponents on the variable, but the principle is the same. Look at the coefficients, 2, minus 4, and positive 8. So what's the greatest common factor of 2, 4, and 8? Well, they're all divisible by 2. So 2 is a factor, but it's not the greatest common factor because I haven't considered any of the variables yet. Each term has at least one m that it's being multiplied by, so m is a common factor as well. Also, look at the t variable. This term has t squared, this has t cubed, this has t to the exponent 5. What's the greatest number of t factors I can take out? Well, 2 of them. So 2mt squared is my greatest common factor for all 3 terms. Okay, so now my other factor, what multiplied by 2mt squared gets me the line above? Well, 2mt squared times 1 gets me 2mt squared. 2mt squared multiplied by negative 2mt gets me this, minus 4m squared t cubed. And 2mt squared multiplied by 4 t cubed gets me 8mt to the 5. So hopefully you can break it down in your mind and work backwards just to check. 2mt squared times 1 gets me 2mt squared. 2mt squared times minus 2mt, well, 2 times minus 2 is minus 4, m times m is m squared, t squared times t is t cubed, so I've got the second term. And lastly, 2 times 4 is 8, m stays m, t squared times t cubed is t to the 5. So I've got my factored form of the expression. Now this last one, n squared plus 3n plus 2n plus 6, resist the temptation here to simplify and put your like terms together. Because remember, we're not expanding and simplifying, we are factoring. Now, if you see something like this with 4 terms, try grouping. So what I mean is, we're going to group the first 2 terms, and we're going to group the last 2 terms. And I'm going to do common factoring for both groups. Well, for my first group, n squared plus 3n, what's the greatest common factor? Just n. Okay, so n times n is n squared. N times 3 gets me 3n. Now my second group, 2n plus 6. What's the greatest common factor? In this case, it's 2. So what multiplied by 2 gets me 2n plus 6? Well, 2 times n gets me 2n. 2 times 3 gets me 6. Now I want you to notice something. Both terms have n plus 3 as a factor. So if n plus 3 is the greatest common factor for this and this term, what do I multiply by to get the line above? Well, I have the n plus 3 times n gets me n times n plus 3, and then n plus 3 times 2 gets me 2 times n plus 3. Okay, so factoring by grouping, take your first 2 terms, find the greatest common factor, and your last 2 terms factor the same way, and then you should notice that you have a common factor again in the brackets, and you're left with n plus 2 as your other factor. Okay, so this is common factoring. We're going to get a little more complex in the next example. We're looking at simple trinomials. Okay, so this is trinomials, means there's three terms, and they're in the form x squared plus bx plus c. Okay, so the coefficient on the x squared is 1. That's what I mean by a simple trinomial. Okay, so you would have learned this in previous grades, but here's a refresher. If I look at x squared plus 11x plus 30, I want to turn it into factored form. So it's going to look like that. Now I know that when I multiply out my factors, I'm going to end up with x squared. So I know that I'm going to have x times x. Now the tricky part is figuring out what two numbers go in the brackets with the x. Now the pattern is always that those two numbers have to add up to, in this case, 11, but they have to multiply to 30. And that's just how it is, because when I multiply these two brackets together, when I'm expanding it, x times x gets me x squared, x times something plus something times x, well, those are like terms, they have to add up to this, and then the last number times the last number, they have to multiply to 30. Okay, so when you're figuring this out, you just have to think of two numbers that multiply to 30, add to 11. If you can't think of those two numbers right off the top of your head, you can always start by making a list. So this is how I do it. I write off to the side somewhere. I know that I need to multiply to 30, add to 11. Okay, so now I just list my numbers that multiply to 30. Start with 1, 1 times 30. Now go to 2, 2 times 15. Now go to 3, 3 times 10. Then I go to 4, but 4 doesn't go into 30, so then I go to 5, 5 times 6. After 5 comes 6 in my list, but I already have it in my list, so I know my list is done, because I'm just going to start to repeat myself. Okay, so these are all the pairs of numbers that multiply to 30. Now I just need to find the one that also adds to 11. Well, 1 plus 30 is 31, so that doesn't work. 2 plus 15 is 17, so that doesn't work. 3 plus 10 is 13, that doesn't work. 5 plus 6 is 11. Those are my winners. 5 and 6 are the two numbers. So I can go back up to my factored form and just plug those in, plus 5 and plus 6. Now the next one, x squared minus 9x plus 20. Try this on your own. Watch out for the minus 9 here. Pause the video, see if you can do it, and come back and check. So we have x in both sets of brackets, in both factors, and we need two numbers that multiply to positive 20 and add to negative 9. So if you need to multiply to become positive and add to be negative, you know that both your numbers are negative. Okay, so negative 4 times negative 5 is positive 20. Negative 4 minus 5 is minus 9. So here we have our factors are x minus 4 times x minus 5. Okay, try this one. X squared minus 6x minus 16. Notice there's two minus signs in this one. Pause the video and try it. Okay, multiplies to negative 16. So if it multiplies to a negative, one of them is positive, one of them is negative. So 2 times minus 8 is minus 16, and 2 minus 8 is minus 6. Now this, believe it or not, is not going to be that difficult, even though we have a minus 2 as the leading coefficient, because notice minus 2 is a greatest common factor. So here I'm throwing in some common factoring, and then once we do that, you'll see it's a simple trinomial as well. So the greatest common factor is minus 2. The other factor has to be x squared plus 6x minus 16. Now this is a simple trinomial. I need to find two numbers that multiply to minus 16 and add to positive 6. And those two numbers are minus 2 and positive 8. Okay, so let's start from the beginning here. The greatest common factor is minus 2. The rest is this. It factors into x minus 2 times x plus 8. So this whole expression that we started with, we can break it down into three factors. Minus 2 times x minus 2 times x plus 8. Now I want to show you this special case. So this is a simple trinomial just like we've been looking at, but it's a special case because it's called a perfect square trinomial. So I'm going to factor this the same way as I did above. So if I look at my simple trinomial, I'm going to set up my brackets. I need two numbers that multiply to 9 and add to 6. Well, it's 3 and 3. So in my factored form, x plus 3 times x plus 3. Well, I can simplify this and just write it as x plus 3 squared. Okay, so what's the big deal here? Why is this a special case? Well, just notice if the middle term divided by 2 squared gets you the final term, this is called a perfect square trinomial. So half of 6 is 3. 3 squared is 9. So if I recognize that this is a perfect square trinomial, I can kind of just skip right to the end. I know it's going to be brackets squared, and the number here in my brackets is always going to be half of the middle term. That's just the way it always works out. So I just threw this in so you can be on the lookout for perfect square trinomials, so you can kind of do a shortcut to get right to the end. Now sometimes you'll have a trinomial with a coefficient in front of the x squared that's not 1, but it's not the greatest common factor. So for this one, 2x squared plus 3x minus 5, 2 is not a greatest common factor. So I can't factor out the 2, so this is not a simple trinomial. We call this a complex trinomial. And the way we factor these is a little more involved. So the way I am going to show you is the method of decomposition. There are other ways that you can factor complex trinomials. You can find lots of different ways to do factoring on the internet. You can find some really cool shortcuts. I am not going to talk about those shortcuts in this video because I just want to show you the underlying principles of the thing. Now the method that I'm going to show you is called decomposition because we're going to decompose the middle term. And the way I do that, in order for this to work out, is that this middle term needs to split into two terms that obviously they have to add up to 3x. But in order for this to work out, it also needs to multiply to this times this. So 2 times minus 5 is minus 10. So I need two numbers that multiply to minus 10 and add to 3. Now remember, if you need help figuring out those two numbers, you can do some work off to the side. We know our numbers need to multiply to negative 10, so list out some pairs of numbers that multiply to negative 10. Then find the ones that add to 3. Minus 2 and 5 are the winners. So my middle term splits into minus 2x plus 5x. Notice that it still is equal to 3x, so I haven't changed my expression at all. I've just split that middle term into 2. Now I'm going to factor by grouping. So 2x squared minus 2x has a greatest common factor of 2x, and the other factor is x minus 1. Because 2x times x is 2x squared, 2x times minus 1 is minus 2x. The second group, 5x minus 5, has a greatest common factor of 5, and I multiply that by x minus 1. Now notice, both these terms have x minus 1 as a factor. So if x minus 1 is the common factor, I'm left with 2x plus 5 as my other factor. So now I have the fully factored form. I am done. Now, using the same method, I'd like you to try this one on your own. So pause the video, try to factor 6x squared minus 7x plus 2, and then come back and see how you do. So I decomposed my middle term into two terms. They need to multiply to 6 times 2, which is 12. So multiply to 12, add to minus 7. Negative 4 times negative 3 is positive 12. Minus 4 minus 3 is minus 7. Okay, so I decompose the middle term. Now I'm going to factor by grouping. So if I look at the first two terms, 6x squared minus 4x, greatest common factor is 2x. I multiply that by 3x minus 2 as the other factor. And over here, the greatest common factor is actually just minus 1. So I'm just going to factor out a minus 1. I'm left with 3x minus 2. So 3x minus 2 is a common factor. I'm left with 2x minus 1 as my other factor. So that's complex trinomials for you. And there's one last kind of factoring that I'm going to go through in this lesson, which is called difference of squares. So the way you can recognize this is just in the name. Difference means subtraction. Squares means you're dealing with square numbers. So for example, 1 squared is 1, 2 squared is 4, 3 squared is 9. So 1, 4, and 9 are all square numbers. 25 is a square number because it's 5 squared. X squared is a square number because it's, well, x squared. Okay, so if I have a difference of two square numbers, it's called a difference of squares. And the way you factor these, it's really straightforward. I'll just show you the shortcut here. So x squared minus 25, well, the square root of x squared is x, so I put an x in each. And the square root of 25 is 5. So plus 5 minus 5. That's it. That's all there is to it. Because now, if I worked backwards to expand my factors here, I should end up with this. X times x is x squared. Minus 5x plus 5x, well, that's 0. 5 times minus 5 is minus 25. So I have x squared plus 0 minus 25, which is just x squared minus 25. Okay, now we look over here. 9x squared minus 4. This is a difference of squares. 9x squared is a square number because 9 is 3 squared, x squared is x squared, 4 is 2 squared. So it's all square numbers. So I'm going to do the same thing. My factors in brackets, 9x squared, well, the square root of that is 3x. 3x times 3x is 9x squared. And then my square root of 4 is 2, so plus 2 in one, minus 2 in the other. And that's all there is to it. Now this last one, it's a little bit different. Always be on the lookout for common factoring. Okay, so if I look at this, minus 4 is actually the greatest common factor. So if I factor out minus 4, that means my other factor is x to the exponent 4 minus 16. Now look at this. In the brackets here, there's a difference. Are these square numbers? Well, we know this is 4 squared. What about this? X to the exponent 4 is a square number because it's x squared times x squared. So x squared is the square root of x to the 4. Anytime you have an even number in your exponent on your variable, that is a square number. Okay, so x to the exponent 4 minus 16 is a difference of squares, so it factors to x squared plus 4 times x squared minus 4. Now, be careful. This is a difference of squares. So I can factor this even further. Because x squared minus 4 is just x plus 2 times x minus 2. Okay, so factor as much as you can. Do we have any more difference of squares? Well, this is a difference, but those are not square numbers. And those are square numbers, but it's not a difference, so we can't factor it any further. This is the fully factored form of what we started with up here. So this was a review of factoring from previous math courses. Some of that you might have to go through again. You're going to probably need a lot of practice with this. Here's a decision tree or a flow chart of questions you can ask yourself when you're factoring. And this is my effort to try to simplify things for you. Common factor first, if possible. Always look for common factors first. If you don't do common factoring when you are able to, it's going to make factoring a lot more difficult for you. So always look for common factoring first. Then ask yourself, is it a binomial or a trinomial? 2 terms or 3 terms? If you have a binomial, so if you only have 2 terms in your expression, ask yourself if it's a difference of squares. If it is, then you factor it. If not, then you can't factor it anymore. You're done. Now let's go back. Let's say your expression was a trinomial, so you had 3 terms. Then you ask yourself, is it a simple trinomial or a complex trinomial? If it's a simple trinomial, factor it like we did simple trinomials. Remember, a simple trinomial, your leading coefficient on the x squared is just going to be 1. If it's a complex trinomial, factor it according to the method of decomposition like I showed you in the previous examples. Remember, a complex trinomial has a coefficient other than 1 in front of the x squared, and that coefficient is not a common factor. Okay, so once you've factored, you're done. Or if you can't factor, then you're done. Okay, so now it's time to practice. You probably need a lot of practice on this. If you get stuck or if you're not sure what's going on, send me an email with your question and I'll get back to you to help you out as soon as I can.